Okay, welcome back. So we're going to look at this question over here, which looks like we've got someone cycling up a hill, all right? And we are told that the equation of this line is y equals x over root 3, all right? Not like that at all. In fact, y equals x over root 3. All right, now we could think of that as 1 over root 3 multiplied by x. So this here is the gradient. Now what the question asks us is, what is the size of this angle which the road makes with the horizontal? And remember that this angle is actually an angle of inclination. And what's the relationship between an angle of inclination and a gradient? That's right. The tan of theta will be the same as the gradient, and there's the gradient, mx, all right? So tan theta is 1 over root 3. Okay, so to find theta, we're just going to shift tan, undo tan of 1 over root 3. All right, and that's a special angle, so in fact the answer is going to be 30 degrees, but just in case you don't believe me, all clear, shift tan 1 over the square root of 3. Oh, okay, that bracket was in the wrong place, guys. There it is, 30 degrees. Okay, so theta is 30 degrees. Okay, then it says determine the diameter of the rear wheel. Okay, now we are given the equation of the rear wheel. It's not in standard form. So we're going to have to put this here into standard form. And I'm going to do that over here. All right? Just so we can see the picture while we do it. All right. So x minus 4 all squared plus y minus 2. And you might be saying, Paul, we can find the center of a circle and put it in standard form in our sleep. And you're absolutely right, and that's what we want. There's 1004. We need to add 16 and we need to add 4. All right, 1004 plus 16 is 1020 plus 4 is 1024. All right, so that is standard form. This here is our radius squared. So we need to square root 1024, and when we square root 1024, we get 32. All right? And that means, remember the question didn't ask for the radius, the question asked for the diameter. How do we get the diameter? We just double up the radius. 64 centimeters is the diameter of that wheel. Okay. Right. Let's take a look at the next question. Right, this question talks about a kite, and it tells us that the longer diagonal bisects the shorter diagonal at 90 degrees. Okay, so in other words, that's cut in half, and this is a 90-degree angle, and the question's asking us to find the equation of this line. Okay. Right, we're going to ask you to pause the video. We're going to ask you to think about that a bit, because remember what we need to find the equation of a line. We need two things. We need a point on the line, and we need a gradient. Okay, right. Pause the video, have a go, and then we'll take a look. Okay, so the first thing that I hope, let's label these points that might be helpful. Right, the first thing we can do is we can find the midpoint of that point, the midpoint of AB. All right, and remember there are two ways of doing this. We could either use the formula, and the formula says add the x values and divide by 2. 2 plus 4 is 6, divide by 2 is 3, and add the y values. 8 plus 2 is 10, divide by 2 is 5. The other way of thinking about that, okay, is to say, how much has my x value changed? It's changed by 2. And if I go halfway, I want to just go half of 2. Either add half of 2 is 1, either add 1 to 2 to get 3, or subtract 1 from 4 to get 3. And then we can do exactly the same to find the y value. 8 down to 2. It's dropping by a total of 6. What's half of 6? Half of 6 is 3. So if I only drop 3, I get to 5. Or if from 2 I go up 3, I get to 5. Okay, I'm hoping it makes sense. It always makes sense. Okay, right, so the reason for showing you the other method, not the formula, is that the other method will allow us to go any ratio down a line, any proportion of a line, a quarter of a line, a quarter of the way, a fifth of the way. Right, the next thing, we've got a point now. Now we need a gradient, okay? And what we can easily work out is the gradient of AB, all right? It's actually dropping 6 and it's running across 2. It's got a gradient of -3. Quite steep downhill, okay? That means that our line, which is perpendicular, okay, is going to have a gradient. Remember, we're going to take our -3 over 1, we're going to turn it over, and we're going to change the sign. So that's the gradient of this line here. Remember, positive gradient going uphill from left to right. Okay, so the last thing we're going to do now is just work out what the equation is. Let's use y equals mx plus c. Okay, let's put in the y value at 5. Let's put in the gradient of a third. Let's put in the x value of 3 and plus c. Now, a third times 3 is just 1. So 5 is 1 plus c. Subtract 1 from both sides. C is 4. Final answer, gradient times x plus 4. And there's our answer. And once again, it looks like that's about right, because that means that this point over here is 4. And if that's 5 there, then that looks okay. All right. Okay, penduli kasi. All right, let's try this one. If you haven't tried it yourself yet, let's pause the video. All right. These two circles touch. Okay. First thing it says is find the center and the radius of circle 1. So we're going to have to write circle 1 into that form. Okay. Then the next thing says, what's the value of P here if these two circles just touch? Notice the word touches in bold. The circles don't cut one another and they don't miss one another. They touch at a single point. Okay, pause the video, have a go, and then we'll take a look at it shortly. Okay. Okay, so let's have a look. Well, the first thing we're going to do is put circle number 1 into standard form. So that's x minus 3 all squared plus y minus 2 all squared. We've added in 9 here and 4 here. That's 13. And here we've got minus 5. 13 minus 5 is 8. Right. Okay, so the center of circle 1 is at 3, 2, and the radius is the square root of 8. Now the square root of 8 is actually 2 root 2. Okay, the center of circle 2 is at 6, 5. All right, okay, now for the two circles to touch, we need the distance between the centers, and that we can work out exactly. Okay, I'm going to call that D. The distance between the centers, we need that to equal the sum of the radii. Right, and this circle here has got a radius of the square root of P. Okay, so the distance between the centers from 6, 5 to 3, 2, okay, that is 3, a change of 3 squared, and 5 to 2 is also 3. We actually get the square root of 18. All right, and the square root of 18 is actually 3 root 2. Right, so we need P plus 2 root 2 to equal 3 root 2. Right, this here is the radius of circle number 2. This here is the radius of circle number 1. Okay, and so obviously P equals root 2. Root P is the radius of circle number 2. So P equals root 2. Okay. Sorry, guys. Messing this up. Okay. That's what we've got. So we've got 3 root... Sorry, we've got... If we subtract root 2 from both sides, we get root P equals root 2. So in fact, P equals 2. Okay, right. What we have noticed is that this radius, okay, this radius here is twice as big as this radius. Okay, so we now want to find the point at which the two circles touch. So if we just draw another picture here, we've got our one circle here, all right? We've got our other circle here, okay? We know this center here is, circle number 1 is at 3, 2. And we know that this other center over here is at 6, 5. And we know that this radius here is twice as long. Let's go with the green line here. As that. Okay, so I haven't drawn that. Actually, those points should be touching, all right? But there we have it. Okay, this is twice as long as that. So we want to go 2/3 of the way along this line. This point will be 2/3 of the way. This is 2m and 1m, all right? 2/3 of the way. So how much has the x changed? And this is where our midpoint formula is not going to help us at all. Our x value has grown by 3. So 1/3 of 3 is 1, and 2/3 of 3 is 2. So we should add 2 to 3, and we're going to get 5. Right, we're going to do exactly the same with the y values. The y's have also grown by 3, all right? And 2/3 of 3 is actually 4, right? 1/3 of 3 is 1, so 2/3 of 3 will be 2, and we must add 2 to 2, and we're going to get 4. All right, that point there is the point 5, 4, and it's where the two circles touch. Okay, important idea. Right, then let's have a look at this question here. And this question has got to do with angle of inclination. And let's just have a look why. So we've got these two lines. This line is not in standard form. This one is y equals a half x plus 3. And this one is y equals 2x minus 5. All right, what I've done is added y to both sides and subtracted 5 from both sides. So the one line's got a gradient of a half. Now a half's not that steep. It's uphill, but it's not that steep. That's this line over here, okay? The kind of the green line. This one, the red line, is quite a bit steeper. Okay? And this one's got a gradient of 2. This one's got a gradient of a half. Okay, now what we're going to do, we are going to use the fact that the tan of the angle of inclination is equal to the gradient. We're going to put a horizontal line on this diagram. Now we can choose where to put it. Let's put it through there. Okay, so a horizontal line. Okay, sometimes this computer draws us a nice horizontal line and sometimes it doesn't. Okay, today it's still, okay, there we go. All right, so are we able to work out this angle? And I'm going to call this angle alpha. Because remember what I'm trying to find? I'm trying to find this angle in here. I'm trying to find theta in here. Okay, can I find alpha? And the answer should be yes. And can I find, let's call this beta? Because if I can find alpha and beta, then, sorry, I'm not trying to find this angle in here at all. I'm trying to find the angle between these lines. Okay, all right, so we've now lost our line here. Okay, we are trying to find theta that's in here. Okay, and what we're going to do, we know that the tan of beta is 2. So beta, we're going to undo tan of 2, and we get 63.4 degrees. Right? Alpha, we know that the tan of alpha is a half. And if we undo tan of a half, we get 26.6 degrees. Okay, and so now theta, the acute angle in between those lines, is just going to be the difference between 63.4 and 26.6. Right, and let's see what that is. 63.4 minus 26.6, and we get something 36.8 degrees. Okay, we're going to stop there. Before the next lesson, have a go at the next few questions. All right, we haven't got too many more pages. I think we've got maybe one more lesson on this. All right, but have a go, and then we'll go over this next time. Okay, look forward to seeing you then. Have a great day, everyone.